Have you ever seen a picture of space so unbelievably remarkable that you think that it can't be real? Well, chances are it was real and it was taken by the Hubble Space Telescope. Now, Hubble travels around the Earth at around 17,000 miles per hour, and it's taken over 1.5 million pictures since its launch in 1990. Hubble has completely changed the way that we see the universe by giving us clearer images, increasing our understanding of the cosmos, and by inspiring future missions to come, such as JWST and the Vera Rubin Observatory. Now, my name's William Pitts, and let me tell you what we're going to get into today. We're going to go over the history of HST, otherwise known as Hubble Space Telescope, when, why, and how it all happens, discoveries and achievements it's made, and major findings because of HST and how it's changed science forever. And we're going to go over Hubble's impacts on the future and missions that it's inspired, such as JWST and Vera Rubin Observatory. Now, before we can get into the discoveries that Hubble has made, let's get into how it all happens and how it all began. It all began on April 24th, 1990, with STS Mission 31 aboard the Space Shuttle Discovery. Now, these 5 astronauts here are the ones that were on the space shuttle and are the ones that put their lives on the line for this to all happen and to better the betterment of society through this endeavor. Now, this is a diagram of the Hubble Space Telescope, so let me explain how it all works. So here and here on the sides are the solar panels, and the opening right here is where it actually takes in all that light to be analyzed. The antennas are on the top and the bottom, and that's how it communicates all the information to the people here down on Earth. And over down in the back here, this is all the camera equipment that's actually used, and it has the primary and the secondary mirror where it bounces off the primary, then the secondary, and then into the camera. Now, when Hubble first launched, it had a major flaw, and that flaw was spherical aberration. The primary mirror in the telescope was manufactured wrong. The curvature of it was incorrect, and instead of focusing all the light into one narrow area for the camera sensor to get in, it was spreading all the light across and making all the images blurry. It wasn't until 1993 when they had service missions aboard other space shuttles go up, and they were able to give it a lens over the camera, and it was able to clear those images, giving Hubble its own pair of glasses. So, now that Hubble has its pair of glasses, let's get into what it could actually see. This first image on the left here is the Hubble Ultra Deep Field, probably one of the biggest images in science history. What astronomers did is they found the darkest, emptiest spot in space that they could see with the naked eye and with ground-based telescopes, and they made Hubble stare at it for hundreds of hours. And what it got was the Hubble Ultra Deep Field. In this image, Hubble was able to see the earliest images of galaxies ever taken, and they were able to see galaxies that formed only a couple 100 million years after the Big Bang, way earlier than scientists previously thought galaxy formation could happen. And it completely revitalized the way that we see the universe formation and galaxy formation. Now, on the right here, we have a Cepheid variable star. Now, what Hubble did with these stars is astronomers had it focus on, so with Cepheid variable stars, they dim and brighten at different times very precisely, almost like clockwork. And so with these stars and Hubble, it was able to study them with greater precision than ever before, and it was able to help us calculate distances in between galaxies that we were never able to do. And it helped us increase our understanding of the expanding universe, and we were able to calculate the rate of that expansion because of these. Now, Hubble's legacy. What it led to was so many future missions. 2 big ones would be JWST right here and the Vera Rubin Observatory. Now, JWST was created as a predecessor to Hubble. It was a bigger and better deep space telescope. And so just like Hubble, it takes pictures very far away in very small areas of the sky, and it can study them in very great detail. And it was able to answer questions that with Hubble's discoveries we came up with, because before Hubble, we didn't even know what we would look at with JWST. And with Hubble, we were able to get bigger and greater questions that had to be answered by bigger and greater technology, such as this. Now, the telescope on the right is Vera Rubin. Instead of going for the very far away, very small images, Vera Rubin focuses on the very big. It takes the widest field images of space ever before. This picture to my left here is actually an image taken by Vera Rubin, and it focuses on sky surveying. So it takes thousands of images of the whole sky every night, and it stacks them night after night, and it creates almost a movie. And it can show the things in the sky moving around, and it can track asteroids and all sorts of other stuff to just understand how the universe evolves. And it can help us study more where it's going rather than these telescopes studying where we came from. In conclusion, Hubble has completely changed the way that we view galaxies. It helped calculate the age of the universe, and it was the foundation for future missions such as JWST and Vera Rubin. This image to the right is the Pillars of Creation. It's probably one of the pinnacles of astrophotography, and it's just another great example of the incredible pictures and research that Hubble was able to bring us. And these are my sources. Thank you very much.